Hi everybody. Today I'm gonna talk about hashing and how you can implement hashing in .NET applications. So for today, uh, I'm gonna speak about what exactly hashing is and what are different hashing algorithm we have in .NET, and then you're gonna see the implementation. Okay. So starting off with what actually hashing is. So hashing is it's a cryptographic function. So basically, it's a cryptographic hash function, and it's like considered practically impossible to invert. And there are basically two main aspect in hashing. So one has to be like a plain text, or this is generally called the message, and on this message you apply some sort of algorithms. So that those are basically cryptographic algorithms which have previously class written in .NET, and you can use those classes to implement the hashing. And then once you apply those classes or those hashing algorithm over your message, you get the digest, or you call fingerprint, or whatever you call. So it's like every message has a unique digest, so it's like impossible for two different messages to have the same digest. Okay, and there are some properties of hashing. So some of the properties are like it's like very easy to compute. So I'm gonna just show you how in really very few steps you can create or you can compute hash on a plain text. And the second property of the hashing, it's impossible to generate message from hash. So hashing is like a one-way technique. So there is only way in, there is no way out. So you can create the digest from the plain text, but it's like impossible to create message from the digest. So there is only one way to create digest from message, and there is no way to create message back from the digest. The third property, it's impossible to modify the message without modifying the digest. So as every message has got its unique digest. So if you are modifying message, you need to modify the digest. So if you are not modifying, if you have just modified the message and you haven't modified the digest, so it's gonna tell you that there is some sort of your message has been compromised, and there are some modification has been done in the message. So if you have to modify a message, then you need to modify the digest. And the last and the most important property, it's more of like a fingerprint. So what I mean is it's impossible for two different messages to have same digest. So every message has got its own unique digest, which is different from the different from some other digest for a message. Okay. Now let's see how you can implement hashing in .NET. So there are some classes written for hashing. So there are different techniques. So you have MD5, you have hash algorithm, plain hash algorithm, you have keyed hash algorithm. So in a while, I'm gonna show you the difference between the basic hash algorithm and the keyed hash algorithm. So in hash algorithm, you have MD5, you have Shea series, Shea 1, Shea 256, Shea 38, and Shea 5112. So MD5 is like it's compromised, and I won't really recommend you to use MD5 in your cryptographic application unless and until you have some compatibility issue or some other constraints. So the best one to use is like Shea 5112 algorithm. Now this unique digit after the algorithm name specify the output, the size of the output which the algorithm is going to generate. So Shea 512 is going to create your 512 bits of output, 338.4. Shea 384 is going to generate 384 bits of output. Same is for Shea 256. Shea 1 is going to generate your 128 bit, not 1 bit. And then MD5 is going to create your 128 bit, but it's like compromised. So not really makes sense to use it now. Okay, so and now let's just see how we can create or how we can implement the hashing in our application. So I'm here, I have my Visual Studio 2012 open up. I'm just going to go to File and then create a new, and I would like to have a, I would like to add a project. So let me go to the other project type, and I would like to add a solution. Okay, so let's call this cryptography channel. This is a blank solution, and I'm targeting .NET Framework 4.5. Okay, so I have my blank solution up here. In this solution, basically, I just need to add a new project, and I would like to have a class library, and I will call this library as cryptography. Okay, so now Visual Studio is creating a new project for me. So by default, I have this class. I would like to delete this class, and then I would like to add a class. Add a class, and I'm gonna call this cryptography. Let's see, oh sorry, I'd like to have this as CS. Looks better. So now we are ready to create our first hash, implement our hashing. So I need to include the namespace. So I'm just gonna add system dot security dot cryptography. Okay. And now what I'm gonna do is like I'm going to create some new functions. So first I need to make this class public class and make it static so that I can use in my project later on. And then I need to add some function. So let's add a function, and I'm going to return a string. So this will be my digest, and then let's say let's call this share 5112, and it's gonna accept a string of message which are on which I need to compute hash on. Okay. So for the timing, I have everything that I need just to implement the code right now. So now first I need to create an object of share 5112 class. Okay. And now if you look at these objects, so share, you just so compute hash, and it accept a byte array of a string. And then also you can have some other overload for the same function, like you can pass byte array, and then you can pass the offset and the count. So from starting up from the string and then considering the next length of the string for which you need to compute hash, or you can pass in some stream of data. So this is my string, so I need to convert this into byte array. So what I'm gonna use, I'm gonna array of message equal. I'm just gonna use encoding, and then use UTF-8 encoding to generate bytes, and I will generate byte from this. So I have now my array of message. I've converted my message into array, and I just can pass this into, and then this will generate my hashed array. Okay, now this is my hashed array, and I'm returning a string, so I need to convert this string back, convert this array back into a string. So what I'm going to do is encoding dot UTF-8 that get string, and I'm gonna pass my hash. So now we have implementation of this share 512 function. So I just need to pass in some message string, and then I will use the share 512 technique to compute hash on this, and this will return the hash value of this message. So now let's add one more project, and this time I'm gonna add some in the phone application where I'm gonna actually use this class library. So starting off with go to the common control, and I just need some label, a couple of text boxes, and then for the timing, let's say go to the panel. I need one panel, and inside this panel, uh, I would like to have some radio boxes, or maybe a couple of those. Okay, and then a little bit of housekeeping. So let's say rename this and call this message. So rename this to text message, and then um, RPT chef 512 if I need to calculate the hash using chef 512 technique, and then RPT share 128 and call this share 128, and then this is going to be my box which will be showing the exact output of the shares algorithm. So I would like to have this as multi-line, and then I need one more label to actually show the byte count or the bit count in the output. So what I need is a label. I don't want the text. I will be populating this after, and I need this as label bit count. Okay, so now one more thing and we are good to go. So what I need is like a button. So button, and name this as button compute hash compute hash. Okay, we are good to go. So we have our UI ready. Just go to the solution explorer, and then I will add the reference to my class library and a little bit of code. So if I have my text box or txt message out text. Oops. So I just need to check if this is actually provided. So we're gonna pop some message through pi. message. Okay, so if I'm a message provider, so what I'm gonna use is if RBT shares checked, and I'm gonna use something else. I'm gonna use else things. So for the time being, I have only share 512 implementation, so we just want to look into this. So what we're gonna do is where what we're expecting is digest, and digest is like CLS cryptography.share 512, and I need to pass my message. Right. So if my digest is if my digest contains anything, so what I need to do is like I need to populate those into my text box digest, and I need to also populate some strings. So where number of bits equal string dot format. So what I'm gonna do is I'm just gonna count the number of bytes in this and then convert those bytes into bits. So where number of bytes equal to text box 2 dot, or maybe digest dot split. I'm gonna split on this and then length. So it's gonna give me the byte number of bytes, and then where actually it's bytes, and number of bits, it's gonna be my number of bytes multiplied by 8. And then I need to the digest contains bytes, which makes it. So now I'm gonna pass in number of bytes and number of bits. So we are good to go. Let's see. Let's run this application. Oh, okay, so I just need to set this as my starter project. Where are you? Set as starter project, right? Build it again and run this. So, hello world, favorite line of a programmer, select share 512 and compute hash. Okay, something really went wrong here, and let's see why these are coming like this. Okay, so let's go back again to a cryptography class, and where I'm converting OKR. So what exactly I need to use byte convert to string, and then convert this byte array into string, and run this again. Again, hello world, and I'm going to share until. Okay, so now you can see that that just contains 64 byte, as I was using share 5 until key algorithm, so it contains 64 bytes. You can see this is 1 byte, another byte, so these are 64 byte, and which makes 512 bits. So I was using share algorithm of 512, so I got output of 512 bits. Now if I use another technique which says share 128, and then but just I need to replace this with 128 and the rest of the code remain same. So sorry, we don't have 128, so I need to use 256. Share 256, and this has to be of type. I just replace this with var. So replace this share 256 again. Share 256 dot compute hash. A little bit of code change here. 256, and then compute hash. This time I'm gonna take this digest outside, so it's of my type string and string digest. Digest, and I need to set my digest equals cls cryptography dot set 256 and txt message dot text dot string. I need to pass in this string, and then rest of the code remains same. Build this again and run this application again. So hello world using stack 5626. So now this contain 32 to 32 bytes, so which makes it 256 bit. And then again, now if you notice, if I just make a small change, let's just change, make this d to with the capital D and then recompute hash. So I'm just going to use share 5 and 12 again. So you see the output is like 2C74F3, and if I just recompute the share on this, so the output changes drastically. So that's like a lot of difference between above and same. Okay, and every time you use the shell version, so hello world is going to be outputted, or the digest will be this way only. Now, this is a really convenient technique to just make sure that you have as an input what you are expecting to be. So you just calculate hash and then save it somewhere, and then you take the input and then again calculate hash on the input provided, and cross check the previously computed hash with the newly computed hash. So if they are same, so just make that the query or the data which has been provided is like there is no compromise with that, and that is what we are actually expecting. Now, going forward on this, this is pretty simple technique. But what can actually happen is that if you have just plain text, and as already mentioned, there are a few handful of technique in .NET to actually compute the hash. So, what actually can happen that if a programmer or if a person really actually want to break into a system, what he can do is like um, he can get a text message or the plain message, and then can use the different hashing algorithm. We are hardly 5 or 6 hashing algorithm that we have, and one or the other technique is surely going to work for him, and he can eventually break into your system. So what you can do is you can add a sort of key to the hashing algorithm or the previously hashing algorithm, and then you need to secure those keys. So once you have the key with you, then you need to pass that key to your hash algorithm or hash function, and then only it's gonna work. So let's just see this thing in action. So what I'm gonna do is I'm gonna back to my cryptography class, and now I'm gonna implement keyed value algorithm. So I'm gonna keyed share 5 and 12, and it's gonna expect some string of message and then some string for a key. What I'm gonna use is like key dash algorithm dot where keyed share 5112 equal new. So I need to go to all the way down to 5112 CNG, and then you have HMA CSHA 5112. So now it has got two parameters. So if you don't provide any, so it's gonna initialize the new object of this keyed share 5112 class with a randomly key generated. Otherwise, you can provide a key. So again, this key has to be in byte array. So I need to convert this key. See, the key has to be in byte of array. So you need to pass in some byte or key. So what I'm gonna use is like where array of key equal, again I'm gonna use UTF-8 encoding to create a key of key array, and I have my key arrays, so I can initialize the class. Now everything else remains the same. This will be keyed share 512, and I need to have array message. Now again, so what I'm using is like I'm passing on the message along with the key. So you need to have the key to just create the hash from the message, and then I can create a new class object using that key, and then compute hash using the key. So unless and until I don't have key, I won't be able to create a hash. So now I can go back here. It's pretty simple. So I just can have a text box and paste it somewhere in the application as long as it can accept a key. So this time I'm just going to accept some key. Um, sorry, I'll rename this as txt key, and then uh, return compute keyed hash, and then just rename this with key hash, and so everything else remains the same. So that is this time would be keyed share 5 and show. I need to pass in some message. So uh, text message dot text, and so let's pause this, and then the thing remains the same. So low volt and passing any key. So now again, this is if I just use share 5 and 2 algorithm on the same message and compute hash, this is different. If I use the share 5 and 12 on the message along with some key, and this is totally different. So this is how you can easily use hashing. So this was just a way how you can create hash, and somewhere down the future, I'm just gonna show you the real world or the practical implementation where you use hash in your application. Thanks for watching this video, and have a nice day.